Let's summarize what we have learned so far. We started as a register indirect addressing mode, where we copy the data from the memory as given by the square bracket and store it to the destination register. So in order for us to copy anything from the memory, of course we need to know what is the memory address. So for register indirect addressing mode, whatever is inside the square bracket, which is R1, will give us the value of the address. So in this case, let's assume R1 is equal to 2000. So the address that we're supposed to load from is given by R1, which is 2000, and we're going to copy the data from this memory location and then store it into register 0. Then we also learn the second addressing mode, which is called the immediate offset. So we also copy from the memory, and the base or the address is given by R1 and also offsetted for a certain amount. So for immediate offset, again, we're going to figure out what is the address based on the value that was located inside the square bracket. So in our case, the address is R1 and plus with 4 as given by the addressing mode. So if you look at R1, which is 2000, so the address is basically 2000 plus 4, and this is where our data come from. So if you read this kind of instruction, basically it means wrote into R0. So the value is coming from the memory. So whatever inside the square bracket will tell you what is the address. So same case for the immediate offset. So the square bracket represents the memory. So whatever inside the square bracket, in this case register 1 and the offset with 4, will give us the memory address. Then we also learn about the pre-index with immediate offset. So we have the square bracket, again representing the memory. The address is given by register 1 and with an offset value. And after that, we have the pre-index operation. And again, we are moving whatever value from the memory into register 0. The operand inside the square bracket will give us the address. So in this case, it's register 1 and 4 as an offset. So we can calculate, since R1 is 2000 plus 4, we have an address of 2004, and this is where the memory location is, and we copy the 4 byte or the words and put it into register 0 as our destination. So if we look at the pre-index with immediate offset, we could divide that into 3 different operations. First, which is for us to figure out where is the destination. So this is where the source and whatever inside the square bracket will give us the address. So after we have moved the data, we have the third operation that we're supposed to complete. So with pre-index, we're going to modify the address or the value you have in register 1 with the new address that we figure out after we do the offset. So in this case, 2004 will be moved to R1. So after the operation, R1 will become 2004. So if we compare with the immediate offset without the preset, so basically we only have two operations. So this is the first that we need to know where is the destination, and the source come from the memory as given by the square bracket. So whatever inside the square bracket will help us to figure out what is the address. But of course, after you have moved the data to R0, there are nothing else for us to do, unlike the pre-index. Well, the reason why I would like you to interpret both addressing mode in such a way is that today we're going to learn another addressing mode, which is called the post-index addressing mode. So the first operand is the destination, as all the root instruction have. The second operand is the source. So again, as you can see, the source in our case come from the memory as given by the square bracket. So whatever inside the square bracket is the one that gives us the address. And we have an extra immediate offset outside of the square bracket. So if you repeat the same interpolation as what we done previously, first we know what is the destination, second we know where is the source, which come from the memory, and whatever inside the square brackets will give us the address. So in this case, register 1 is happen to be 2004. So you have to move the data, and the data come from 2004, which is the memory location, and again transfer the data to register 0. So after we have done the operation, we have the third, as what we do in pre-index, which is supposed to update the register 1 with the new address value that we figure out just now. In post-index, we have the address, which is come from register 1. So the post-index will give us an immediate offset. So in this case, it's a 4. So 2004, which is where we get our address before. And in this stage, this 2004 have to add it with the offset and end up to be the new value will be 2008, and this is the value you'll be replacing register 1. So at the end of the operation, register 1 will turn into 2008. So for normal immediate offset, once we figure out what's the address, which is 2004, and we transfer whatever value you have in the memory on the address 2004 to register 0, then since there are no more stage or steps afterwards, so we're not going to change anything on register 1. So for the pre-index with immediate offset, the offset is given inside the square bracket. As what we have learned so far, whatever inside this square bracket is the one that gives us the memory address. So in this case, R1 is 2000 plus 4 is 2004. So we have to transfer the data from 2004 to register 0. And after we have done the transfer the data, we have to complete the pre-index operation. So by replacing register 1 with the new memory address that we figured out just now. And lastly, when we have a post-index, the offset value actually is outside of the source or the square bracket. That's why it's called a post-index. So we are transferring the data from the memory to the register 0, where the address is given by the R1 itself. So our R1 just now was 2004. So we are copying, or we are moving whatever data you have in 2004 and move to the register 0 as our destination. So again, once we complete the transfer data from memory to the register, we have to do another post-index operation where we have the address added to the value we get from the immediate post-index offset there, and in this case is 4, and the new address is 2004, and this value will be override or replaced with the register 1. And there you have it. We have the addressing mode for immediate offset, and we have the pre-index with immediate offset, and lastly we have the post index with immediate offset. So we're going to redo this exercise, but instead of we using the pre-index addressing mode. So we want to try how it's going to look like if you are using post-index addressing mode. So let's redo our exercise by using a post-index with immediate offset. So as usual, we begin by initializing the address pointer with R0. So the initial address is 2000. So after we executing the code, you're going to get 2000 in register 0. So then we also going to initialize register 1 with the value of 8000 as the pointer for the destination address. So after we executing the code, R1 will become 8000. So again, similar approach as what we used previously. So we're going to copy the address from the 2000 into a register. Then we store back the value into our 8000 memory. So of course today we're going to use a new addressing mode, but with the post-index immediate offset. Then what happens after that is we're going to store whatever value we have in register 2, so back to the memory, but this time the address is not given by R0 but register 1, because this is where we're supposed to duplicate or copy the beta 2. So of course after we have moved the data, we would like to increase my address pointer R1 with 4 so that we can go to the next value. So let's try to understand these two first before we go further. So we try to move a data from the memory to the register 2. The memory address is given by register 0 because that's the only things that you have within that square bracket. So our R0 is 2000 as where we initiate in the beginning. So that's why the address is 0x2000. So of course in 2000, this is where the data can form, and then we're going to move this value there. So after we transfer the data, we have to also complete the post-index operation. So by adding the 2000, which is come from the address, with this value, so the value is 4, so 2000 plus 4 equals to 2004. So and the value 2004 will be replaced to register 0. So then we store whatever value. So just now we just move A, and we're supposed to have 4 bytes of whatever value, let's say it's A, and back to the memory, the address is given by register 1, which is 8000. So our address is 8000, and we're going to move this one to the memory. So, and also we have a post index operation to complete. So 8000 plus 4, the immediate value you found in the post index, and replace the register 1. So similar to register 0, register 1, after you transfer or you store the value into the memory, this value will change from 8000 to 8004. So then we going to branch to the label again. So it will be somewhere there. To instruct our processor to repeat the same process over and over again. So every time we come back to root R2 register 0 with a post index of 4. So currently R0 has updated to 2004. So when we come back again, you're going to move the memory from the memory to register 2. The address in R0 is no longer 2000 as what we initiate in the beginning, because the post index has changed it to 2004. So on the second time when you come back, so we are actually reading the data from the address 2004 and transfer the value, in this case B, to register 2. So same things happen to store instruction, because in the first operation we have changed the register 1 because of the post index from 8000 to 8004. So on the second round, when your processor branch back to again, and when you need to store back register 2 back to the memory, the value your processor read from register 1 is going to be 8004. So that is the location where he need to transfer B from register 2 to 8004. Of course, in our store and root and store operation, after you have transferred the value from memory to register 2, you're supposed to do the post index operation. So previously it was 2004 and plus, but now after you transfer the data 2004 and then add another 4, so this value will become 2008. And same thing happened to register 1. So the original was 8004. So after you have moved the data from register to the memory, the address or the value in register 1 has to be changed from 8004 to 8008. So then your processor come to the branch of course again, and there are no conditions for this branch, means he will always go back to again, and he will try to route again the data from the memory into register 2. The address is given by register 0, which now the value is 2008. So, and this is where the data will come from the memory, and let's say the value is C, and C will be transferred to register 2. And after we transfer the register 0, we'll have to go through again the post index operation. So 2008 plus 4 will become 0C. So then when we store back register 2 back to the memory, the address is given by the register 1. So current value of register 1 is 8008. So this is where we're going to transfer the value from register 2 back to 8008. So then after that we have to finish the post-index operation. So 8008 plus 4 and it will become 0C. So of course in this case, since we only need to move 3 words, so at this case after we have transferred the C to 8008, we should write something to tell our processor to stop rather than keep looping back to again over and over again. So we can reuse our method in our previous video by comparing register 2, but in this case whether the register 2 is equal to the immediate value of 200 and C, because this is after we have transferred the 2000 data from the 2008 to register 2. Register 0 has become 2000C, and this is where we're supposed to stop because we have successfully moved 3 words into the 3 memory there. So if this is equal, if register 0 is equal to 2000 and C, so we said let's branch if these two value is equal, EQ represent equal, and we use a label done, and done supposed to be somewhere down there, and we might have some other operation to do, but this gonna be telling our processor to skip this branch again, but instead of jump over the branch again to somewhere in the down there, so that we skip this loop operation. So this was the answer that we have in the previous video by using the pre-index addressing mode, and this is what we have covered today using the post-index addressing mode. To do the similar operation, of course there are another version that we try to solve the problem using just the immediate offset. So of course there are no rights and wrong which addressing mode you should use, or you could actually mix and match between the post-index or pre-index, or even immediate offset, or even just register indirect. So this completes the topics today, and I will see you in future videos.